Okay, this problem is a bit cut off, so I'll just read it as it is here. And I already have listed down our knowns and our equations, along with a constant. In the figure, particle 1 of charge 1 microcoulomb and particle 2 of charge negative 3.7 microcoulomb are held at a separation L on x-axis if particle 3 of unknown charge Q3 is located such that the net electrostatic force on it from particles 1 and 2 is 0, what must be the coordinates of particle 3? So, given this, let's see, yes, we can say that knowing k, q1, q2, all over r squared, we can assume the particle here is positive and at a certain unknown distance here, which we are to solve for. So plugging this in, we have 8.99 times 10 to the 9th, and this is going to be times 1 times 10 to the negative 6 q3, and this is going to be over distance x, because this is going to be q1, q3, which is right here. And this is going to be equal to 8.99 times 10 to the 9th. And this is going to be 3.7 times 10 to the negative 6q3. And this is going to be x plus L squared, whole thing. So immediately, we can cancel the constant and the unknown q3 since they appear in the equation on both sides. So once we remove those, we are left with this. Now if we square root both sides to help us with our, what would this be, the denominator? Then we get immediately, this gets away, and we remove this. And on top of this, the times 10 to the negative 6 can go away on both sides, because it, again, appears on both sides, leaving us with this, and the square root of 1 is 1, so our equation now looks like this. Now if we do this weird cross multiply, or whatever they call this, we're going to have a 3.7, square root of 3.7x equals x, I think this would just be x plus L. So now, let's see. We could divide both sides by x. Can you divide that? Because I don't think you can, because there's a plus sign here. So no, we can't do that. So now, how can we solve for x from here? How do we get x alone? Well, we can plug in L. This is going to be 0.15. And then we can move it over here, but then we divide x by x. Which I don't want to do that. So we have x on both sides, man. Okay, so what we could do is we could factor out the x here. And this, you know, by subtracting x on both sides here, this would be x 3.7 minus 1 equals 0.15, and then we just divide this by the square root of 3.7 minus 1. And that should give us x equals this, which equals which equals 0.162 meters, which we can turn into 16.2 centimeters, which is how the problem asks for it. And that is the answer for the x-axis and the y-axis. That's the worst y ever. Y-axis equals 0 because it's not going up or down. Everything is along the x-axis. So for this to be an equilibrium, of course, y would have to equal 0.